video, I'm actually going to be combining two sections because they're both pretty simple and straightforward. I'm going to be combining section 10.1, which is about outcomes and events, and the other one I'm going to be combining is section 10.2, which is dealing with probability. Now, with that said, out on section 10.1, we're introduced to a couple of terms. The first one is experiment, which you've heard before, and it's simply this: an investigation or procedure with varying results. Case in point, I have a bunch of little cubes here. My experiment is to pick one of these at random. And if I pick one of these at random, I'm going to have all these possible results that you see before you, which goes back to the concept of outcomes. All the possible results of all of these are different outcomes. So I have an outcome here, so forth, so on. And if I wanted to be more specifically, I can actually say that these are an outcome. My browns colors will be an outcome, black, white, and purple. All of these are different outcomes, which gives me to something what we call an event. So in my experiment, I'm actually not going to look here. I'm going to stir it up and I'm going to say I want to pick a white cube. That is my event. I'm trying to pick a white cube. And I can pick that at random and, well, it doesn't win. But that would be my event, a collection of more outcomes. I'm trying to get the white cube. Or maybe I wanted the black cube or the pink or so forth, so on. And then there leads me to the concept of favorable outcomes. It's the outcomes of a specific event. So if we were to say that again, that I wanted to pick a white cube, the only possible way that I can get a white cube is by picking the only white cube in there. That is my favorable outcome, is getting one white cube. Or what if I changed the event? My event was to pick a pink cube. Well, how many different ways could I have got that? Well, I could have got it two possible ways, and that would be my favorable outcome. So let's kind of walk through some of these things a little bit more specifically. And if you notice, I've got some stuff already written down. I actually recorded the entire part of this video already, and to realize that I wasn't recording, I was just talking to the empty classroom. But anyway, go figure. So let's go with this thing. It says a bag is filled with 4 red marbles, 3 blue marbles, 3 yellow marbles, and 2 green marbles. You randomly choose 1 marble from the bag. Find the number of ways the event can occur and find the favorable outcomes of the event. So, I want to have an event of choosing red. It says, find the number of ways the event can occur. Well, if I've got 4 red marbles in a bag, that means that I can get a possibility of choosing red 4 possible times because there's 4 red marbles. Which leads me to the next piece. It says, find the favorable outcomes. Well, my favorable outcomes are I can choose the red marble, or I can choose a different red marble, or I can choose a different red marble, or I can choose the last red marble. These are all my favorable outcomes. There's 4 possibilities of me getting it, and there's 4 different colors, or 4 of the same color I'm getting, but they're each individual. So it's like red marble 1, red marble 2, red marble 3, red marble 4. All right, choosing green. According to this, there are 2 green marbles. So the number of ways that I can choose green are 2 possible ways because there's only 2 green marbles. So what does that mean? My favorable outcome is I either pick the green marble or I pick a different green marble, and I still get what I want. Choosing yellow. This time there are 3 yellow marbles, so there are 3 possible ways that choosing that event can occur. And how does that happen? I either choose the yellow marble, the other yellow marble, or the other yellow marble. Okay? Now this next one, number 4, is a little bit different. It says choosing not blue. So I'm going to kind of write this out, and we need to realize that we're not wanting blue. So I could theoretically get 4 red marbles, and that would not be blue. That would be cool. I could get the 3 yellow marbles. That'd be good. And I could get the 2 green marbles, and that would be good. So a total of all this up would be 9. There are 9 ways that this event can occur by not choosing blue. I can choose the reds, I can choose yellows or the greens. And so how does this work? What are my favorable outcomes? Well, I could choose the red marble, the other red marble, the other red marble, and the other red marble. Or I could choose the yellow marble, or I could choose the other yellow marble, or I can choose the other yellow marble, or I could choose the green marble, or I can choose the other green marble. And these are all my favorable outcomes. Now, that's really the concept that's happening here. So I want you to look at number 5 and see if you can figure this one out on your own. It says, in order to figure out who will go first in the game, your friend asked you to pick a number between 1 and 25. What are all the possible outcomes? And what are the favorable outcomes of choosing an even number? And what are the favorable outcomes of choosing a number less than 20? All right, so for the first one, basically, I just listed all the numbers out from 1 through 25. Those are all the possible outcomes, 1 through 25. And then it says, what are the favorable outcomes of choosing an even number? Well, I just wrote the even numbers, 2, 4, 6, 8, all the way through 24. These are all my favorable outcomes of picking an even number. And then lastly, it says, what are the favorable outcomes of choosing a number less than 20? Well, basically, I wrote 1 through 19 out. These are all my favorable outcomes. And that's pretty much it. That kind of gives you the basic understanding of how outcomes and events occur. An event is what you are trying to accomplish, and the favorable outcomes are getting what you want. Okay, that's basically what's happening here. All right, so that leads us to the next section, 10.2, which is dealing with probability. All the things that we just talked about before, we kind of put all that information together, and we end up getting a number that measures the likelihood that an event will occur. And you've seen stuff like this before. We kind of normally do it as like a percentage, but we can either write it like as a fraction, or we can write it as a decimal, or we can write it mostly as a percentage. And if you have the number 0, that means that it is impossible to do. So let's give for instance here, I want to know the probability of me being able to pick a pink cube out of these 2 cubes. It's impossible. There's no pink cube there. All right, so it is impossible. But now let me do a different question. What is the probability of me picking a brown cube out of these 2 at random? Well, it's absolutely certain. I'm either going to pick this one or this one. So I have a 100% chance of getting a brown. But if I were to change the problem ever so slightly, what is the probability of me getting a brown? Well, I have a 50-50 chance. It's equally likely that I could get the brown, or equally likely that I would get the pink. And I could change it up some more, add a couple extra things. It changes the likelihood of me getting a pink versus a brown, or vice versa. So generally speaking, if you have a percentage or a number that says around 25%, it's more than likely not going to happen. Whereas if you have something that's around 75% chance, it's likely going to happen, just like we understand with rain. It's pretty straightforward, nothing really complicated of how we do this. So this kind of leads us to the next piece here. It says, describe the likelihood of the event giving its probability. There's a 30% chance of snow tomorrow. Well, that means that it's unlikely going to snow. So unlikely, it is going to snow. Oops, can't spell. All right, and that's really all this is. Then the next one says, you solve a brain teaser 0.75 of the time. Well, we know how to change this to percent. This is a percentage, so this would become really 75% of the time. So we can simply say that the likelihood of you solving that, it's very likely to happen. All right. That's it. So you get a brain teaser, you're more likely going to solve this because it's basically 75%. So how do we get all this information? How do we get these percentages? Well, let's go back to our little numbers here. It says, you randomly choose 1 hat from 3 green hats, 4 black hats, 2 white hats, 2 red hats, and 1 blue hat. Find the probability of the event. Well, the first thing I actually want to do is look at all the possible outcomes. So I can pick 3 greens, 4 blacks, 2 whites, 2 reds, and 1 blue hat. If I were to add all these numbers up, it would give me all the possible things, but I want to show you. So I can get a green hat, I can get another green hat, I can get a third green hat, or I could get a black, a black, a black, or a black. I could get a white, a red, and a blue, okay? These are all the possible outcomes that I have by choosing or picking a hat at random. So how many do I have altogether? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And that makes sense because if we were to add all of these numbers up, 3 plus 4 is 7, plus 2 is 9, plus 2 is 11, plus 1 gives me 12. So there are 12 possible outcomes. Now, I need to find the probability of choosing a red hat, and this is the way I do it. I take the number of possible outcomes, which happens to be 12, and we've done something similar with this when we work with percents. We take what we're going to get, the possible value, the maximum I can get, and then I'm going to put that on the bottom of my fraction. Choosing a red hat is basically 2. So I have a 2 in 12 chance of picking a red hat. And we can change this to a fraction to be 1/6. All right. And if we wanted to, we can change this into, check our calculator out by putting 1/6 into our calculator, and we can change this into a decimal by going second PRB. Gives me that. And I get 0.16666, so we could have another probability of 0.16 infinity. And if we wanted to change that into a percentage, we can multiply by 100 or move our decimal, and we basically have a 16.6% chance. So in order for me to basically, when we're looking at it, all of these are my probability of picking a red hat. And if we think about it, it means that our probability is very low. We're very unlikely to pick a red hat at random just because of how many hats there are. Let's look at the possibility of choosing a black hat. Well, we know that there is a total of 12 possible outcomes that we can get, and the black hats happen to be 4. Well, we can simplify this to be 1/3. So we have a 1 in 3 chance of getting a black hat. And if we were to look at the percentages, that's about a 33.3% chance, okay? Looking at not choosing a white hat. This is very important. It says not choosing a white hat. Well, it says that we have 2. Well, think about it this way. There are 12 possible outcomes, and we don't want a white hat. That means that there are 10 possible ways that we can choose not getting a white hat. Because since there was 2, 12 minus 2 is 10, and there's 10 possible ways. And when we go to solve this, we have 5, 6, and we can look at the percentage of that if we want to, just to kind of show it to you again. 5 divided by 6, there's about an 83% chance that we are going to get a color that's not white. So it's very likely that this would happen, that we don't choose white. Choosing a blue hat, same concept, and we just put it over 12, and let's go ahead, and it was 1/12. And if we look at that in as a fraction, it would be about a 8.3% chance of choosing a blue hat. Why don't you try 7 and 8 on your own? So for number 7, you should have got that there's going to be about a 2 in 3 chance of not choosing a black hat, which is about 66.6% chance. So it's pretty much likely you're going to choose something that's not a black hat. And then the last one says not choosing a green hat, which would be about a 3/4 chance, which is around 75%. So this is also very likely that you're going to choose a hat that's not green. Let's look at number 9. It says the probability that you draw a mechanical pencil from a group of 25 mechanical and wooden pencils is 3/5. How many are mechanical pencils? Well, there's a couple things that we need to understand here. We know that first off, there are a total of 25 mechanical and wooden pencils. So that is all the possible outcomes that I may have. So I'm going to kind of set up a proportion. I'm going to write the number 25, and so this would be like my total pencils. And I'm going to put my probability on the other side of my proportion. And this 3/5, this 3 represents the chance of me getting a mechanical pencil out of 5 total pencils. So basically what we've got here is we've kind of did this, we're doing what we were doing up top in reverse. This time I know my probability and I know the total number that I started with. It's just that I got to figure out how many mechanical pencils there are. So what do? Well, it's just a matter of cross multiplying and dividing. So I can say 25 times 3, 25 times 3, divide by 5, and I get that there are 15 mechanical pencils. Now, this is only just one example of how we can use probability to figure out different types of questions. And a lot of these are getting ready to pop up on you very soon in some of your assignments. So if you need some questions, give me a holler. But for the most part, probability should be fairly straightforward because it's just using proportions again. And it's the same concept with what we've been doing with working with percents and decimals. It's nothing really changing. It's just that we're just using that material in a different context. And that's it for this video. You, as always, ask questions, and I'll see you in the next one. Bye-bye.